It's Dave Asprey with the Bulletproof Executive. I just had a shot of espresso made with upgraded coffee beans, so I'm talking a little bit fast, and I apologize for that. But it's worth it because I needed to maximize my brain power for today's guest. He's a total badass. Before then, though, I want to say thanks. Thanks because you've made this podcast #1 on iTunes, and I really appreciate it. If it's been helping you, I'd also appreciate it if you went to bulletproofdietbook.com and registered in order to get a copy of the Bulletproof Diet infographic for free and the first chapter of my book for free. This is going to help me go to publishers and explain to them exactly how many people want to read the Bulletproof Diet book so I can get the right book deal. I really appreciate your support there. bulletproofdietbook.com. And now, who is this amazing badass we're talking about? This is a guy who, probably the only guy I can say, literally saved my career. And this is Steve Fowkes, who is the master of smart drugs, the author of Smart Drugs and Nutrients 2. He blogs at projectwellbeing.com, an executive director of the Cognitive Enhancement Research Institute, the CEO of Nanopolymer Systems Corporation, a co-founder of Vitamin Research Products, this company that introduced major nutritional products like DMAE, selenite, BHT, and tyrosine to the whole industry. These are things that you see written about all the time. I talk about using tyrosine. This is now 20-something years later. He has a bachelor's in organic chemistry. He's a former pyromaniac child. The books he's written include Wipe Out Herpes with BHT. By the way, that rocks. The GHB book. And he knows something about Alzheimer's disease because his grandfather passed away from Alzheimer's. It helps that maybe he was a dentist and smoked and had emphysema that contributed. But Steve knows things that I don't know. And his influential newsletter series called Smart Drug News is what turned my brain on. When I first started having brain fog in my early 20s, I went to Alta Vista because Google wasn't really around then. And I found Steve's newsletters online. And I read every single one of them. And I bought the stuff he recommended. I had to order it from Europe at the time. It turned my brain on enough to keep learning and to go down the path of biohacking. So, Steve, thanks, man. I appreciate that, and I appreciate you coming on the show today.
You're welcome.
It also helps that, Steve, you are a regular attendee and advisor to the Silicon Valley Health Institute, the anti-aging group that I'm the chairman of. So every month, if you are in the Bay Area, on the third Thursday, you can go to Palo Alto at the community center there, and you can actually see Steve in real life. He has this aura around him that comes from all the smart drugs he's taken, and there's a circle of people asking him questions all the time. This is pretty accurate, isn't it, Steve?
Yeah, it is.
All right. Maybe the aura, I'm exaggerating, but he is an incredibly well-acknowledged expert and someone who's accessible to the community, and he runs Project Wellbeing meetups as well. So, Steve, really, I'm in your debt, and I asked you to speak at the first Biohacking Conference that we put on last year, and we'll be doing another one this year. And of course, you're perennially invited because you have this massive skill set. Welcome to the show, man.
Thank you. It's great to be here, and let's have some fun.
The reason I invited you on is that, well, I think we could talk about like 50 things, but you are into hacking pH in a way that I'm not. You know, I take alkaline water, it gives me the runs, and I think a lot of the alkaline claims don't make sense to me. I'm like, the human body is a battery. If some parts are not acidic, they don't work very well. That would be your digestion. Other parts of you need to be alkaline, and there's a delicate balance, and I think a lot of the marketing stuff I've seen, all the various things I've tried, haven't worked out that well, but I haven't tried your protocol. And you've given some fantastic talks about pH and circadian rhythm. So we're going to talk about acidity and alkalinity and get your take on it, because you have the most rational scientific approach to this I've come across. And there's a lot of like woo-woo, alkaline water blessed by fairies and stuff like that. So first off, is fairy blessed water better?
In my opinion, no. It might be to some people a slight source of reducing equivalence. So, we live in an oxidizing environment and we need reducing equivalence to stay alive, but the problem with water is that it doesn't carry much. It's like all voltage and no amperage, and therefore if you put one drop of an oxidizing agent in it, the reducing power of the water disappears. So it really isn't the same thing as, let's say, eating a pineapple guava, where you're going to get a gram of vitamin C and that's going to have better reducing effects on your body, or the alternative of eating MCT oil or coconut oil and having it rev up your mitochondria, which will produce reducing equivalents dynamically at the cellular level.
I understood all of that, but I think everyone who's listening to the podcast right now, driving in cars, either ran into a median trying to think about it. So let's break that down, so to speak, electrically, and let's talk about why reducing matters to people, and just explain what reduction is in layman's terms, so we can start to talk about why alkaline water or other alkalizing herbs or diets might be helpful.
Okay. I think that's easy to do with a temperature and color analogy. That we live in an environment where the outside world is oxygen. It's an oxidizing environment, and you think of it as being hot, or think of it as being red, which would be a color of heat. And it's a fundamentally dangerous environment. When you go into our bodies and look at what happens down at the cellular level, it turns out that our bodies are cold and blue, and that there's that fundamental antagonism that we have to defend, that we have to keep our body temperature cold in order to survive. And that is the energy that we expend in our life. We bring in fuel, we burn it, we get rid of CO2. We use that energy to keep our bodies cool so that the oxygen in the atmosphere isn't dangerous. It can be cleanly directed through the mitochondria to produce energy without damaging our DNA, our proteins, our minds, other kinds of sensitive molecules in our body.
Okay, and the act of reduction there is, what are you doing specifically with the oxygen?
Well, you're not doing anything with the oxygen so much as you're just channeling the oxygen in a way where the oxygen can't accidentally damage something that's critical, like your genes or important proteins or structures in your mitochondria where you're generating energy. In a sense, you can think of it as a kind of entropy pump where the universe is disordered and our bodies are ordered, and we're using that energy to create order. And so we're borrowing order from the universe to keep it in our bodies, and we're dispersing disorder into the universe, and that takes energy to do it, and oxygen is the source of that energy. But because we are a highly reduced environment, a very cold environment, a very blue environment, that surrounding heat, that redness and energy and heat is a potential threat to our systems. And so when we lose that ability to keep our bodies cold, we end up dying. And this is the process of life. We have to borrow energy from the world in order to keep our structure intact so that we have the knowledge in our brains and the structures in our body and the health of our vascular system, and et cetera, et cetera.
Okay, that makes sense. And the act of reducing something there is basically maintaining that balance between the energy of oxygen and the destructive oxidizing nature of oxygen.
Yeah, you can think of it as a refrigerator. Okay. An antioxidant is like an umbrella that protects us from the sunlight. So it doesn't really cool us, it just prevents us from heating up from direct sunlight. But the mitochondria are like a refrigerator. It's actually cooling our bodies down. And we need that refrigeration. If all we had was antioxidant protection, we would not survive. We need to have that actual drawing down of the temperature below baseline so that we can then cool off the hot spots of our body, which would be caused by free radicals or by cosmic rays or by eating rancid fat or having an infection or being allergic to a wheat protein, that kind of thing.
Okay, so these are different environmental stressors. And what does an environmental stressor do to your pH?
Typically it's a acid stress.
Okay, so an acid stress comes in, increases acidity of the body. And what impact does that have on our ability to stay cool, so to speak, but our ability to effectively operate as biological creatures?
Well, we need to have a certain pH range in which we operate for our cells to be healthy. And it's somewhere around the vicinity of 7 in terms of our body and somewhere around the vicinity of 6 in terms of our urine, because our bodies do produce enough extra acid that we need to dump that acid in our urine, and so our urine shows a net acid influence from the pH of the rest of our bodies.
Okay, so your blood and most of your meat should be around, and probably your saliva then should be around 7, and your urine should be around 6.
That's right.
Okay.
And so by studying that dynamic, you can get some insight into how your metabolism is working. So, for example, during the day, we run a large net acid production because our mitochondria are tuned up, our immune systems are highly active. We can run into things. We could get bitten by insects and by snakes and lizards and spiders, and we could run into antigens. So viruses, bacteria, that kind of stuff. All of that requires us, when we're out in the world, to have an active defense mechanism, which is our immune system. And so our immune system is highly active during the day, and it's driven by acidity. And our energy system, when it goes into high gear during the day, that produces a net of acidity. So that's part of our natural rhythm. And when that acidity is being generated, our kidneys are taking the blood that's going through and any extra acid that's being generated and dumping it into the urine. Well, after the day is over, we go into nighttime mode. This is when we're sleeping, and this is when we're repairing. We need to be alkaline at that time. So our energy systems drop down. So the acid that's being produced by our energy systems goes down, and then our kidneys will start conserving acid to keep us balanced. So our urine will go from, let's say, 5, which is 10 times more acid than average, to pH 7, which is 10 times less acid than average. And so we can see this kind of tide where we swing from acid during the day to alkaline at night. And this is a natural rhythm. And if this doesn't happen, you are at risk for developing cancer and other degenerative diseases.
That makes a lot of sense, Steve. And the idea that we're changing on a daily basis. I mean, we have almost every hormone that we have goes through a circadian rhythm. So why wouldn't our acid-alkaline balance? And probably also our CO2 reserves also, which affect acidity very directly. You get those from breathing. Those also probably have a cyclical thing. Is it just directly tied to acid-alkaline the way you're asking, or is your CO2 separate? Because you breathe differently when you're sleeping, so your CO2 changes, or is that just a part of the acid of the body?
Well, the body balances its breathing based on pH control. Most people think, since we're breathing oxygen and we need to have oxygen from the air, that our breath is controlled by regulating oxygen. Well, it isn't at all.
Yeah.
There isn't an oxygen sensor in the brain that's controlling our breathing. It's actually controlled by carbon dioxide, which is the byproduct of oxygen. And so if your CO2 goes up, you tend to breathe more to get rid of it. And if your CO2 goes down, you tend to breathe less to conserve it. And that's all built into the wiring of the nervous system, the autonomic nervous system.
So what happens when I drink what I happen to be drinking now, San Pellegrino, which is relatively acidic? It's full of carbon dioxide, right? But it does have some calcium, magnesium, and some sulfate in it. What does ingesting CO2 through the GI tract do to this whole balance? Am I completely jacking it up?
You are jacking up your CO2, absolutely. And this is a great self-care test to experiment with yourself. Would be to look at something in your life that would be directly related to CO2 levels. And my suggestion would be breath hold time.
Mm-hmm.
How long can you hold your breath? If you just take a deep breath and hold it, when do you have to breathe? Is it 30 seconds later?
Like 6 minutes.
Is it a minute later? Is it a minute and a half later?
Yeah.
And that makes a difference, because if your CO2 is low, you can hold your breath longer. It takes longer for your CO2 to build up because it's starting at a lower point. But if you drink a bunch of CO2 water, or you take some baking soda that would have CO2 in it, raising your CO2 up, then you can only hold your breath for a short period of time before you hit that ceiling, and the CO2 forces you to take a breath.
It's interesting. I tend to have high CO2 in my blood. I don't think it's from drinking Pellegrino. A bottle a day isn't that much. But it's funny. I should be excessively acid, according to most of the nutritional people telling us what to eat, because I eat meat and fat and all those coffee, all those evil things, bacon. But I'm consistently alkaline, and to the point that if I take baking soda or even too much magnesium, I start panting at night. Like it doesn't feel good. which is one reason that I'm kind of suspicious of these people who say, well, if you burn your vegetables and test the pH of the ashes, that's what happens in your body. Is there any rationale to that?
Oh, yeah. I mean, that does happen. But the regulation of pH is a higher level function. And so, for example, if you are parasympathetic, sympathetic balanced, and your heart rate variability is in the green zone.
So what that means for people listening is we're talking about fight or flight response.
That's right.
So
if you go into fight or flight response, that sympathetic activation that causes you to breathe more rapidly and to breathe shallow, and that blows off carbon dioxide. Okay, so CO2 is the CO2 release is dependent upon the style of breathing. So if you're breathing shallow, then you are blowing off CO2, and if you're breathing slow and deeply, you're conserving your CO2. So being centered and not being nervous is actually, it influences your resting CO2 level.
So
when you go into a doctor's office and you get a CO2 assessment, you're typically measuring yourself in a highly stressful environment, the white coat syndrome, and so you'll tend to be breathing more, and in terms of driving through traffic to get there and waiting in the issue and being irritated because your appointment is 25 minutes late and these kinds of things, you will tend to blow off more CO2, and that'll influence your reading. So some of these kinds of tests aren't particularly useful, but when you take it into your own home and you start studying things like your breath hold time and how it responds to different things that you might do, you can actually learn a lot about what's going on with your metabolic rate.
Interesting. So a potential biohack for people listening would be once a day when you wake up, when you go to sleep, hold your breath for as long as you can. But there's a training effect too. If you do that regularly, you could just get better at it. But
yeah, and I was a lifeguard and a swimmer in college, and I could hold my breath for 2 minutes easily. And even though, according to my metabolic type, I should have been able to hold it for 45 seconds to maybe a minute, a little over a minute, I could hold it much longer because of that training. So the point is, though, that it's not so much about how long you hold your breath, it's about how it changes dynamically for you. It's all about so if you can hold your breath for a minute and a half, then you're looking at, only being able to hold it for a minute or being able to hold it for 2 minutes as being a significant change in your CO2 state. Whereas if you can only hold it for 30 seconds, then going to 40 seconds is a significant change in your CO2 state.
Okay. So then, is it because I'm too alkaline that I start panting when I take baking soda or something like that? Literally, I feel like I just have to breathe really shallow, really fast breaths.
Yeah, you're blowing off. Well, no, that would just be CO2 loading.
Okay, so
you can load CO2 with baking soda, and you can load it with carbonated water. And, one's alkaline and one's acid, but it's still a CO2 load.
Oh, okay.
So that would tell me that it's all about the CO2 for you. And, whenever you drink carbonated water or you're taking baking soda, you're just loading yourself up with CO2. Now, you could take an alkalinizing agent that didn't have any carbonate in it and see a totally different effect.
Interesting. So I need to play around with that. What would an example of a non-carbonate alkalizing agent be?
Lemon juice.
Okay.
Yeah.
But
eating some seaweed.
Isn't lemon juice acidic?
It's acidic on your tongue and it's acidic to your stomach, but it's alkaline ash when it burns in your body. So that's, again, going to that kind of question. So lemon juice would be tart on your tongue, and therefore you might think it's acidic, but it's not. But the ash is very alkaline. But seaweed is even more alkaline than that, and that doesn't have any acid or alkaline taste to it at all.
So if you put a pH meter in lemon juice, though, it actually is acidic.
That's right.
Right. So the body doesn't burn things. If we did, we could eat candles, and we would be totally happy on that. So why does a chemical reaction that doesn't happen in the body, we do that to lemon juice, why does that tell us what's going to happen in the body? I'm very skeptical that that's a reliable, 100% accurate indicator. Like, you burn your food, and it's going to tell you what the food's going to do in your body, because we don't do that.
We burn food, yeah. So you burn the carbohydrates in the citric acid, things like that in the lemon juice, and there's also other kinds of residues in the lemon juice that would be left over. So if you have, let's say, potassium, that's going to change your pH. And so once the fruit acids are burned off, depending upon how they go, you're either getting an alkaline effect or an acid effect from it. The ultimate pH that you're left with is more about the ash than it is the pH of the food itself.
Okay, so the point there is...
Let me give you an example. Citric acid, very tart. Pucker your mouth big time.
It's an acid.
You rearrange the carbon and hydrogen atoms and you get sugar. Not tart at all.
Right. Right. So the question there is whether a combustion process with heat is leaving the same residue as a metabolizing process. And I've always been suspicious of that, but I've never had, great evidence otherwise. It seems like, the reactions that are driven by high temperatures when you burn something are just not like what happens in the body. So the residues would be different in the body.
They are alike in terms of, O2 and carbon in and hydrogen in and water and CO2 out. They're alike in that respect. But you're right in the sense that, let's say if you are anaerobically dominant at the time that a food comes in, the sugar is going to burn to lactic acid instead of burning to CO2.
All right.
And that's going to affect your pH balance because CO2 flows from the cell out through the tissue to your lungs and is efficiently mobilized and flows from your body, whereas lactic acid comes out of your cells and sticks in your tissue and doesn't move very well. So that's your classic acidic American body type from the traditional Chinese medical, kind of message. And that's why most people will say, alkaline is the way to go. And, they're not recognizing that they're only talking about one layer of the body. And under that layer and above that layer, you also have pH effects that are not at all connected to it. And it's not uncommon to see somebody with lactic acidosis on the tissue level have blood alkalosis.
Interesting. All right. So now I'm sure some people listening to this are lactic, acidic, and their eyes are crossing because we're getting pretty scientific pretty quickly here.
Yeah.
There's a point to all this, though, that's really worth understanding. And it's that you can measure your pH at different times of the day, and that's going to tell you tweaks you can make to your diet to increase your performance, increase how you feel, and increase even your health level. So what's the best way that someone listening to the show could go out today or tomorrow and measure their body's acid-alkaline balance, their pH? What's your recommended method?
Well, it's not something that people should do if they're not really dedicated, because when you want to measure your pH, because it's a dynamic rhythm, you need to measure it every time you pee, and typically for 3 to 5 days in a row in order to be able to verify that the acid and alkaline swings that are taking place on one day actually correlate with the swings the next day and the day after that. That in a sense you're looking at your overall pH rhythm rather than looking at the fact that you had salad for lunch one day and chili for lunch the next day.
It's sort of like like when women track their morning temperatures for ovulation calculations. The day-to-day changes might not be that important, but you can tell when overall it's climbing or overall it's falling. So this is something for people who really are willing to spend a week understanding how their body works. But listening to the show, we have all kinds of people who, they drink Bulletproof coffee every morning because they feel better. They wear a Nike Fuel band or a Basis band. They're doing all kinds of stuff because they're willing to invest that. The kind of people who come to Silicon Valley Health Institute meetings. So let's assume that people listening are willing to, basically carry around a little bundle of sticks or something else, and every time they pee, measure it. What do you recommend? Is it a pee thing or is it a saliva thing?
Well, I recommend urine just because I understand it better. And so if somebody does some urine measurements and they submit the data to me, I look at it and I can make sense of it faster.
Got it. So okay. You recommend people pee on a strip and write it down. That's right.
And track it over time. And if you collect your pH data on one side, you want to collect how you feel on the other side. I'm feeling, plus, better than average, 0, neutral, negative, worse than average, negative. I'm really, can't get out of bed this morning. That kind of data can help. And also tracking, when you drink a cup of coffee, when you eat a meal, whether the meal is high protein or low protein, whether it might contain, let's say, wheat, and you might be allergic to wheat. All of these kinds of things can be correlated with the urine pH changes, so that you can learn by associating, some prospective cause with an effect. Okay? So this is all a learning process. Now, for those people who aren't willing to be, to dedicate their life to this kind of thing, because, carrying around pH papers with you all the day and having to think every time you need to go to the bathroom, measure my pH, and have a notebook to write it down.
It's good for 5 days.
It's a lot of overhead.
Yeah.
And if you're at work, you got a contract that's coming up, you got, some deadline, how much of your coping power can you dedicate to this kind of thing can be a real challenge. But look, for those people who aren't in that kind of position, there's a general rule about pH, and it has to do with how you handle your energy. Do you produce energy aerobically or anaerobically, which makes a huge difference on your pH control, and in terms of how do you handle alkaline food. Do you handle it gracefully, or does it derail you? So if you are, let's say you've got multiple sclerosis or some kind of autoimmune disease, chronic fatigue syndrome, and you eat something that's highly alkalinizing, it's likely to derail you. It's likely to make you feel really, really bad, especially if you do it first thing in the morning. And so that tells you that if you're paying attention to this, just not bothering to measure urine, but just paying attention to the kinds of themes that I'm describing, you can say, okay, I'm having a problem generating acid and generating energy. The energy I'm generating is going into lactic acid instead of CO2, and therefore the alkalinity that I'm putting into my body is overwhelming it's not balanced with my acid generating system. So on the other hand, if you are aerobic, you're now, when you eat a high alkaline meal, your body can raise its energy level to balance it, and it doesn't derail you at all, and you actually feel better.
So for people who are, say, endurance athletes or people who are exercising a lot, then they're probably going to benefit more because they tend to be in an aerobic mode more often?
They'll be in aerobic mode more often.
Right. So you have to be in aerobic, not anaerobic,
yes.
Right?
Yes.
Good catch there. That could be off a little bit on the radio.
Yeah, and they're the kind of people who would thrive on a highly alkaline diet. They'd be able to eat fruit, they'd be able to eat veggies and raw veggies and lots of veggies. Because their aerobic capacity would be augmented by their exercise.
So now here's the weird thing. The Bulletproof diet recommends like 9 to 11 servings of vegetables. Like I eat tons of vegetables. And I've got like pro athletes, like world champions who are on the Bulletproof diet, and it's totally upping their game, right? But they're eating tons of fat, like not these alkaline breakfasts. They're doing classic Bulletproof coffee, right? And coffee isn't considered an alkalizing food, at last I checked, right?
No, it is. Coffee is.
It is
highly alkalinizing.
It is? That's so interesting.
Yeah.
It's been a while since I studied
It's a boomerang food, like chocolate.
Yep.
Coffee and chocolate have this 2-hour acidifying effect and an 8-hour alkalinizing effect afterwards.
See, I didn't know that about coffee. There's not a lot about coffee hacking I haven't read, but I would love to see like any data on that, because that would be an amazing post. So you get 2 hours of acidity in the morning, and that's going to probably make you feel good because you were turning on your acid in the morning because you wanted to essentially turn on your immune function and go out and seize the day. And then the alkaline this is enhancing endurance, essentially?
Well, it can. There's some really interesting stuff that's been done by people who've been experimenting, that they've shared this kind of stuff with me, that if you approach exercise, and people have an inclination to exercise or not. If you're in an acidic state, you're inclined to exercise. You're in an alkaline state, you're inclined to just kick back and relax. And so what they found is that if you take something that's acidifying prior to exercise, you go into the exercise better. You initiate the exercise, you're more enthusiastic about it, but you also hit the wall faster. And so the people with the best results do acidification prior to exercise, and then immediately once they've started the exercise, they alkalinize at that point, and that gives them the stamina to withstand long-term exercise.
Wow. And you just got this from data because I mean, you are like the master of biohacking some of the stuff that I haven't done, like acid, alkaline, pH. Like I've played with it. I have a digital pH meter and all that stuff, but I've never graphed it out like you have. So, so this is where that data comes from. There isn't like a formal study of that. Wow.
No.
I wonder. All right, let's
But
talk.
you know that there is, from the perspective of lactic acidosis, as a pathology associated with long-term exercise.
Right.
So people hit the wall because they burn through their glycogen. They hit the wall before their fat burning turns on, or they get the burn that happens from lactic acidosis. And these kinds of things are recognized as encumbering factors for people working out, and especially peak performance.
Wow, this is I've never seen this published anywhere. The first time I've seen it in public, a thing about coffee, and that's really cool, Steve. I have to learn more about this, but we probably don't have to dig in further on that one on the show. But that does explain why some of these incredibly high performance athletes are really into it. What about using the brain octane, the extra short MCT oil, or even just regular MCT oil? At different times of the day? Does your acid alkaline circadian rhythm affect what the best times are to take something that's going to give you more BHB, coenzyme A, and ATP?
Yes, absolutely. And so that would make a difference, for example, in terms of your bulletproof coffee, where you're getting butyrate or MCT oil in it, depending upon whether people are using butter or not. And that will rev up your metabolism and helps shift you from a low energy, low metabolic state at night when you're sleeping into a high energy state of the day. So there's that transition from alkaline to acid, from low metabolic rate to high, from low CO2 to high CO2, that can be facilitated. And so, it matters for you whether or not you are in tune with that process, or that process is late. If you're a night owl, for example, that process is going to be delayed 2 to 4 hours. So when you wake up in the morning, you're still metabolically kind of asleep. And that's that, groggy, oh God, I got to get out of bed, where you need an alarm clock and that kind of thing. Then you have the opposite people, who are the morning larks that just pop out of bed, bright-eyed, bushy-tailed.
Those people
are making, no prejudice on this show, right? Okay. Those people are making that transition from alkaline to acid in the late stage of the morning before they're actually waking up. And so they pop out of bed, and for those people, you have a totally different pH pattern. Their acid momentum is fully developed, whereas a night owl type, it's retarded.
So if you're an early morning catching worms kind of person, what's the best time to drink your bulletproof coffee?
It might be never.
No, don't say that, Steve. No, okay, so these are people who might not benefit from coffee at all.
They're naturally doing bulletproof without the coffee.
Okay,
and
from a CO2 perspective, right? But what about like the anti-inflammatory stuff that's present in there, the polyphenols and all those things?
It probably would be best to spread it out throughout the day, because their acid momentum is already going.
Well, let's actually separate it out. Okay, there's coffee, there's butter, and then there's MCTs. So we could talk about those different components. So let's say that you're one of these people and that you've peed on a stick for a while, and that you tend to be acidic when you first wake up in the morning. You wake up at 6 a.m. and you're ready to seize the day. You go to sleep at 8 p.m. because you turn into a zombie at night. Okay, so you're like the opposite of me. So if you're one of those people, what's the best time for butter, best time for MCT, best time for coffee?
I would say later in the day. I would either be lunch or dinner.
Okay, so these guys might actually, this is interesting. So if you were going to do, like, I think you know about the bulletproof intermittent fasting. The idea that when you start your fast, 0 protein, 0 sugar, just bulletproof coffee in the morning, and then you just don't care about food. So these guys might actually benefit by having a full breakfast and then doing
or an alkalinizing breakfast, because let's say if your rhythm is shortened, instead of having a 25-hour biological clock like you or me, they have a 23-and-a-half-hour biological clock. So they tend to fall asleep in front of the television at night, or a little bit earlier every night. And so for them, going to sleep is not the problem. The problem is they wake up at 4 a.m. or 3 a.m. They're just too much. So they want to lengthen their day. So when they're swinging acid in the morning, if they have fruit for breakfast or veggies for breakfast, they eat, let's say, some spinach for breakfast, that's going to bring down their pH and extend their day.
Okay, but wait, how is fruit going to do that to their pH? I thought fruit was supposed to be
It's an
alkalizing.
alkalinizing influence.
Right, but
That's all.
aren't they
So,
already? Aren't they already? Or I guess they're super acidic. So you want to
no,
blunt.
they have acid momentum,
Okay.
so they're stacking an alkaline food on
Uh-huh.
it. So, for example, somebody who wanted to do something that wasn't with sugar could do milk for breakfast because
Okay.
milk protein tends to be an alkalizing protein. Or they could do beans for breakfast, where the bean is an alkalizing source of protein, ignoring the leptin and other
All the
complements.
reasons you shouldn't eat beans and milk
But
protein.
so I'm just talking about
Yeah,
it
I
from
get
a
it.
superficial level, and the body, of course, is three-dimensional instead of
Yeah.
one-dimensional. But okay,
This is just an acid alkaline discussion, right? Yeah,
that's right.
I get it. So I still stand and say that milk protein, and at least most milk protein outside of certain whey and beans are generally not the best foods for the human performance. But your point there about eating something different in the morning could make a lot of sense. So you're one of these people, and you wake up in the morning, you want to add alkalinity, but you want to stay in ketosis because we know that ketosis increases brain function, it's anti-aging, and it's basically the cool state to be in at least 5 days a week. So if you want to do that and you want to have an alkalizing breakfast, what do?
Eat some raw greens.
Raw greens, okay, but I mean, you're getting all that oxalic acid. Raw spinach leaves a film on the back of your teeth, which is your body trying to dump those extra acids, like a kidney burden, kidney stones, all that stuff.
You can do a green juice.
Okay, green juice. Why wouldn't you just take a little bit of baking soda and then drink your bulletproof coffee and be done with it?
Well, because baking soda is a shallow alkalinizing agent.
Oh,
and
it's not deep enough.
you want to affect your rhythm down at the cellular level, deep in your body, where your biological rhythms are less superficial.
Okay, so this is something that I don't know about, the depth of alkalizing, like from a cellular biology perspective. And so this is one of those reasons that people saying alkalize or die or whatever. You look at that stuff and you're like, okay, you want to be alkaline, you can be alkaline like that. So what's an example of a deep alkalizing chemical or supplement?
Potassium would alkalinize at the cellular level. Sodium would alkalinize at the blood level.
Okay, so
cesium would be a deep alkalinizing agent at the mitochondrial and nuclear levels.
All right, so now I'm going to just pull out the biohacking big guns. I used to take liquid cesium, by the way. So you're like, okay, I'm a world-class athlete. I wake up at 6 in the morning and I want to shred mountains or whatever. So I'm going to wake up and I'm just going to pop a cesium capsule or take an ounce of cesium liquid, which is the stuff I had. So I'm going to make myself super alkaline, even though I'm in the middle of this acid phase, and I'm going to chug my coffee or eat my bacon because I want to stay in ketosis, and I'm going to go win. Is that going to work?
Well, if you don't overdo it. I mean, you need to have an acid momentum in the morning, and you need to have acid momentum when you're initiating exercise.
Got it.
And so you don't want to sledgehammer it when a ball peen hammer will work just fine.
Got it. So you've got me wondering. And so far, the most effective thing I've seen for, I would say, 95% of the people that I've worked with and feedback I've had is bulletproof coffee in the morning. It rocks people's entire day, and it's kind of mind blowing. And I've had a few people who they don't handle the MCT very well in the morning. It gives them GI dysfunction, and a couple people who've said, I get a racing heartbeat from it. And for those people, they're always on thyroid meds, and they always end up needing to reduce their thyroid meds because their mitochondria is working better. So if someone's listening to this and they do this regular practice and they feel good on it, how should they know how to tweak it other than if they don't want to walk around peeing on sticks for 5 days? Is there an obvious way to know this?
Well, no. I certainly don't know that kind of simplistic formula for it, because on some level you don't know whether or not your racing heart is reminiscent of thyroid or not unless you've experienced that, and you say, oh, that I know what that is because I've been there, and it's not some life-threatening thing where you panic and go to the emergency room.
The two people it's happened to they knew they were on thyroid meds. They said, "Oh, this is a thyroid problem." They backed off on the thyroid and like, "Wow, I suddenly cut my medication." Yeah. Okay.
Well, that they're probably way more astute than the average person on thyroid meds, because a typical person who goes to a doctor and gets a thyroid prescription, they get a dose, and then 30 days later they come in and the doctor goes, how are you doing? And they goes, no. And so, okay, things are, they measure the thyroid and they're okay. And they never know what hyperthyroidism feels like. And so they're just, they're as much in the dark as people who are not taking thyroid.
I have a confession to make, and I'm going to tell you this because you're going to laugh at me.
I'll laugh at you in advance.
There we go. So about a year ago or so, I tweaked my anti-aging testosterone dosage, and I keep my levels in the normal levels where they should be. I'm not like super juicing or any of that weird weightlifting stuff. Me, anti-aging kind of thing. And I've been doing it for 10 years, and everyone knows I'm public about it. So I had tweaked it with the help of a doctor, and it activated my thyroid more. At the same time, I was doing a photo shoot for Creative Live, this big course I taught, and I had to hold a plank pose on the whole body vibration plate, the Bulletproof Vibe, for 5 minutes so they could get the right picture. And if you've never tried doing a plank pose on a whole body vibration plate for 5 minutes, it is an enormous metabolic load. And I ended up getting basically soreness on my sternum from the vibration of the ribs in my sternum. So I had chest pain, a lot of chest pain. At the same time, my thyroid dose cranked up. So I had chest pain centered on the left side, and I had thyroid arrhythmia. And my wife's an ER doctor, and she's like, I think you should go to the ER for that. I'm like, oh, man. So I'm sitting there, they stuck these electrodes all over me, and I'm like, it was my thyroid medication. I feel like such a doofus. So thus are the dangers of biohacking.
Well, that's true. And everything that you learn, well, let me put it this way. Most of the lessons that are most precious that you learn are the result of a mistake.
Yeah, that's very true. Another common mistake is disaster pants. You take way too much of the MCT oil, particularly, less so for the brain octane. You will really be friends with the bathroom for a little while, but you also learn your tolerance for it, and you learn how much to put in your coffee to feel good. So, all right, let's talk intermittent fasting. Do you use intermittent fasting? Do you recommend it? What does it do for acid alkaline, stuff like that?
I do, but I don't recommend it because of the acid alkaline thing, but because, natural humans were constantly we're fasting constantly because of a lack of food availability. And since we don't have that, imposed upon us, we have to impose it upon ourselves. So the whole idea that the human animal is given to adapt to some steady state of life, I think is a fiction of modern society, and that when people were alive in the old days, let's just pick, 20,000, 50,000, 100,000 years ago, food was a iffy thing. And so we were constantly going in and out of ketosis. We're constantly being aerobic and anaerobic. We'll have episodes where we're running away from a bear and climbing a tree, and then other times when we'll be kicked back and partying.
Right. And so making your life more like that is beneficial because you get hormetic change for different things.
That's right.
I get it there.
That doesn't kill you makes you stronger. Well, that's not necessarily true, but that challenges you does tend to make you stronger. And therefore, the more kinds of challenges you have in terms of, high protein, low protein, no protein, high carb, low carb, no carb, kind of things. And going through autophagy, as when you have no protein available and all you're eating are greens that you can harvest as you're hiking through a mountain pass, those are the kinds of stresses that humans would have, and that every time you do that, you're pinning your metabolism up against a wall and inducing an adaptive response.
Yes.
And the same thing happens with pH. We have buffering systems in our blood. Our blood pH is highly constrained, and so we have these two buffering systems, alkaline buffering and acid buffering, that are oriented like this, which keep our blood very, very tight. Now, if you are in an environment where you're eating an acid loading diet, your alkaline buffering system is on all the time and your acid buffering system is weak. And if you then switch to a highly alkalinizing diet, it switches the opposite way. So the buffering systems adapt to the kind of stresses that they have to manage.
Kind of like if you only get to eat something for a while, your body will adapt to digesting and eating that food, and that's how it is. So one of the reasons that the new Bulletproof diet infographic includes the idea of a day of protein fasting is exactly that. You want autophagy and you want to shake things up. It's the same reason that years ago I used to try and be in ketosis all the time. And not only does that suck because you don't get to eat some very delicious foods, but it's actually not that good for you compared to cyclical ketosis, which is where the diet evolved, and that's what I'm recommending to people today. And the differences they have are pretty significant.
Mm-hmm. And I agree, and I would even say that even though it's more convenient for us to pick a once a week breaking of ketosis or a twice a week breaking of ketosis, that would never be that ordered in real life, and that it might even be better to say, okay, this week I'm going to break ketosis twice, and then I'm going to go for 2 weeks without breaking it at all, and on my birthday I'm going to drink single malt, and therefore I'm going to break it, on that day just because I haven't had single malt in a year, and so you're playing to that part of your mind that would otherwise be yammering at you, go for this, and you're just giving it a day when it gets to play so that it shuts up the rest of the time.
There's a lot to be said for that, especially midwinter. When it's cold and dark, you probably ought to be in ketosis most of the time. In summer, less so. And besides, the peaches are ripe. Okay, fine. Did you have some fructose those days? Get a little advanced glycation end product and raise your triglycerides? Yeah, probably. But it was worth it, right?
See, it's never dark in winter in my life because I have red light therapy that I do to encourage the early morning and late evening, the dusk and dawn effect. So I'm adding to that kind of effect so that I don't have the darkness issue.
Well, you just said red, not blue, and it's kind of funny. I was reaching for my remote control. I have bright red LEDs on right now that you see this side of my face is kind of reddish. So I typically have red lights on all day, but I use this, my 1,000 watts of halogen light. So I'm like, hey,
That's
buddy,
blue.
It's like daytime. So I've got blue here, and the red's on until I go to bed, but it's on all day too.
Yeah.
So let's talk.
So the light spectrum does shift from red dominance in the morning to blue dominance in midday to red dominance in the evening. And so I just encourage that so that the issue of the photoperiod adjusting around me doesn't end up, giving me seasonal effective effects.
You know what? We're going to talk some more about what color light when, because we actually haven't even announced this yet. So we're doing a double podcast with Steve today because Steve is just so knowledgeable. What we're going to do now, Steve, is we're going to end this episode, and everyone listening, go ahead and subscribe on iTunes, and next one in a few days is going to be part 2 with Steve, and he and I are going to continue talking. We're going to cover what color lights you should have when, and I'm going to tell you how for $30 you can get exactly this in one fixture that even looks kind of cool. It's dirt cheap, easy to do, and it actually affects all kinds of systems in the body. So we're going to talk about some light hacking, which is why Steve is awesome. We just talked about peeing on strips, what time of day to eat your coffee or to eat breakfast, and now we're talking about lights. And I'm telling you, Steve can not only keep up with me on all this biohacking stuff, he can run circles around me. So you're going to hear all that. Just stay tuned. Come back in about 3 days when we post the next episode. Thanks, Steve. We'll ask you the top 3 in the next episode.
Then how it feels when women have other body parts wet.
After that experience, I just assume that women are so much better at handling pain than me that I'm just not into that waxing thing for myself anymore.
My wife is always, we'll be driving down the street and somebody will be running and I'll be like, oh man, that valgus force on her knee is killing me. I can't believe that leg whip she has. Oh, she needs to see it, and she'll just roll her eyes and save it kind of thing.